Hi guys, today we're going to work on Module 4, Lessons 1 and 2. Now, this video might be a little longer just because it's 2 lessons in one, but it's full of very important information in regards to our new module, which is all about geometry and probability and statistics. So the first half of our module will be talking about geometry and the important key things you need to know in geometry. For this lesson, we're putting 2 lessons together. So we are going to be identifying, recognizing, and drawing points, lines, line segments, rays, and angles. And we're also going to be determining if angles are greater, less than, or equal to right angles. And we'll find out what right angles are in this lesson, in the first part of this lesson. So I'm going to try to zoom through some pieces of this lesson. I'm going to pause and pick out the very key, important things for you guys to know. So make sure you pay very close attention because we're putting 2 lessons into one, okay? So for this lesson, you're going to need a blank piece of paper or your whiteboard, but remember when you're drawing on your whiteboard, it's easy to erase that dry erase marker. So a blank piece of paper might be more helpful to you. And you're going to need a straight edge. If you don't have a ruler, you can always use the spine of a book, or you can take a piece of paper and fold it like I folded my paper here. Okay, so I just folded it in half lengthwise and then in half one more time. So I have four or 2 folds really. Okay, so I folded it here. So this is this would be a great straight edge, just something to keep your line straight when you're drawing. Okay, I'm going to turn my video off so that we can focus on the actual lesson. Okay, so the first thing we're going to do is we're going to think about a specific location on the paper. I want to identify or mark a specific location on my paper. So here's my paper. Okay. So think about how could we mark a specific location on the paper? Well, some of you might have said a dot. Maybe we could do a dot, or we could do an X. Okay, so for our purposes, we don't need all of these excessive lines for an X. So we just want to use one dot to identify our location on our paper. Okay. Okay. So on your paper, I want you to mark a very specific location on your paper. It can be any location you want. It does not have to be the same as mine. Okay. Next, you're going to place your pencil tip on another location on your paper. So you want to mark a second location on your paper. There's my second location. Your second location can be anywhere you want it to be. Okay. Notice that the dots or points that you drew were probably in different locations. How many points do you think that you can draw on this paper? There are a number of many different points you can draw on this paper. So many, we could draw points until the whole paper is filled up. Okay, when we draw our dots, they have a size, but really the point is almost so small that you would need a microscope to see it. Those are what points are, but we denote them using our dots on our paper. Okay, so to identify, so these are points. And to identify them, we can label them with a letter. So I'm going to label this one A, and this one B. So I want you to go ahead and label your points. Let's see. My straight edge moved. Okay. I'm going to try that again. Here we go. Okay. So let's identify what we drew with using these two endpoints. So this line both begins at point A and ends at point B. So those are called endpoints. And endpoints are the points at the end of a line segment. So this is from A to B is a line segment. And segment just means part of something. So a segment or a line segment is just part of a line. Okay, so the way we note line segments, we can note it as line segment AB, and we're noting it with just a little line on top of it. Another way we could note a line segment is by writing it this way, backwards, BA. Okay, because if we were just looking at this line segment on a piece of paper and didn't watch somebody draw it, you wouldn't know which side was the starting point and which side was the ending point. So it really doesn't matter. They're both talking about the same line. Okay, our next step is to draw one more point. Your point can be above your line segment, beside your line segment, below your line segment, wherever you want it to be. Okay, this point is going to be point C. And point C should not be located on line segment AB. Okay, so now we're going to use our straight edge to draw line segment AC. Okay, so we're going to draw . Okay, you could also make line segment AC longer and extend it past the 2 points. So let's see. Okay, if you had a really big piece of paper, you could extend it very, very, very far. Okay, and if your paper went on forever and ever, you could make your line go on forever and ever. You could extend it super far. Okay, so when we note a line segment at the end with an arrow instead of a dot, that is just a line. And lines go on forever and ever and ever, and they never stop. And the way you note a line is almost the same as a line segment, but it has 2 arrows on the end. Okay, so this is line AC. So what is the difference between line AC and line segment AB? Okay, so our line AC goes on forever and ever, and line segment AB ends at both endpoints. You could also write line AC like this. Line CA. Okay, your next step is to draw point D. Point D should not be located on line segment AB or anywhere on line AC, including the parts where it might extend to. Oops. Here's my point D. With your straight edge, you're going to draw a line starting at point B and extending through point D. So we're going to start at point B and extend through point D. Oh no, hold on. Oops, there we go. Oh. How is this one that we just drew different from the other two we just drew? Well, what we just drew from point B through point D extends on forever in one direction. That is called a ray. A ray extends from one point through another point forever in one direction. So we would label this as ray B, D, and we would draw it with just one arrow on the end. Now, before with line AC and CA, we could write it either way. However, we cannot write ray BD as ray DB. Why do you think that is? Ooh. Why do you think that is? Think about it. Hopefully, you said that we can't label it ray DB because the arrow is pointing in this direction and not past point B. Okay, the next thing you need to do is draw point E. Make sure point E does not lie in line with ray BD, line segment AB, or line AC. I'm going to put E. I think I'm going to put E right here. And you want to draw a ray through point E. Mine goes through my letter E, which is fine. Okay, so now we have ray BE that we're going to note starting at point B, going towards our E. Okay, now, are you ready? Touch point B with your pencil. Trace along the line to point D. So I'm going to touch point B with my pencil, and I'm going to trace along the line to point D. Now, touch point B again and trace along the line to point E. Where do these two lines meet? Very good. They meet at point B. Both of these rays are connected, and they kind of look like the corner of maybe a triangle. Both rays start at point B and extend out. And any two rays that share the same endpoint create an angle. We can call this angle DBE. And the way we note it is with a little symbol like that, an angle symbol. Another way we can write it is as angle EBD. Notice how I put the B in the middle of both of the ways that I wrote our angle or noted our angle, because B is the middle point where the two rays connect. That is called a vertex. So a vertex is where our 2 points connect, which is our two rays connect at an angle, which is point B. Okay, you can note an angle in a diagram using a little curly Q like that, showing that we have an angle right there. Okay, so we have an angle right there. Identify another angle in this diagram. You might have said angle CAB right here. Okay, you could have said angle ABD right here. Okay, next you want to go to the bottom of your paper or a new piece of paper. I'm going to go to the bottom of mine. And you want to sketch a rectangle. Okay, use your straight edge to keep your line straight. Okay, do you see any lines or line segments? Do you see any angles? I see 1, 2, 3, 4 points where some line segments meet. And in between those points, I see 4 line segments. 1, 2, 3, 4. And then I also see 4 angles. 1 here, 1 here, 1 here, and 1 here. Line segments are actually, so angles are made with rays. We know we talked about 2 rays connecting to meet at a vertex, creating an angle. However, I don't see any rays on this picture. But when you have a point, we can identify any point on this picture, and we can show that that is a ray, because this point here and this line right here extend on forever and ever and ever. So our ray here, this ray, keeps going forever and ever until it stops right there. So there's our ray, and then we have another ray going the other way. Okay, let's label these points so we can name some line segments and some angles. So I want you to identify 4 line segments in this rectangle and 4 angles in this rectangle. Okay, hopefully you identified line segment A, B, B, D, or you could write them the opposite way, so BA or DB, C, D, and CA. Okay, we see angles C, A, B, that's this one right here. We can see angle A, B, D. We can see angle B, D, C. And we can see angle C, C, A, B. Here's a figure that should look familiar to you. This is a kite. This kite has points, line segments, angles, rays, lines. Okay, so looking at this kite, think about all of the line segments in this kite. We know we have line segment AB, BC, EC, AE, and then we have these ones in the middle. Line segment AD, DC, BD, and DE. What about BE? Is BE a line segment? Or AC? How about AC? The answer to that question is yes. Even if a line goes through multiple points, because we know we can have numerous points on this line. Okay, we can have an infinite amount of points on our line. They just are not represented currently. But we could add any point to our line, and that would be part of the same line. So if I added a point here, point F, line segment BF is part of the same line as line segment BD. Okay, and then we also have multiple angles. Okay, so we could have angle BCE. We could have angle BCD. We could have angle DCE. Okay, what other angles can you identify? Identify at least 3 more angles in this image. Okay, some other angles you could have identified are, let's see, angle ABD. That would be this one right here. Actually, let me use the highlighter. ABD. We could represent angle, oops, ADE. We could represent angle ACE. Oh my gosh. There are so many different angles you can show on this image. Okay. Okay, for the next part of our lesson, you're going to need this page, which is page 15 in your Learn workbook. You're also going to need a blank piece of paper. You can use your straight edge if you want, okay, or you can get another blank piece of paper. And I'm going to turn my camera on so you can see me. Okay, so for this part of the lesson, we're going to take this paper and we're going to fold it in half twice. We're going to fold it hamburger style. Okay, and then we're going to fold it in half again the same way, hamburger style. Okay, so when you open up your paper, you'll have a line going down and going across. Okay, so look at this paper. Do you notice any angles on this paper with your fold crease? Okay, there are a bunch of angles. 1, 2, 3, 4. Okay, all of these angles are called right angles. And right angles are just like the edge of a rectangle or a square. Okay, they're square angles. Okay, so you're going to use this piece of paper. You can use it folded to help you out with your other angles. Okay, so okay, so this is our right angle template. Okay, so the paper we just folded is our right angle template. So we're going to take this and we're going to use it to measure against these angles to see if those angles are greater or less than the right angles. So you want to line up your paper, which actually I'm going to show you a square on my screen. Okay, so I found a way to get a square, a perfect square, so that we can use it as in representation of our paper on my iPad to show how to test if an angle is a right angle. So here we can see I put this square on a corner. Okay, and both angles match up. They meet right there. Okay, so we're going to try it on this one. Okay, so we want to make sure our square, at least one side is lined up with the side of your thing. So we can see here that this angle is less than a right angle because the line does not line up directly with our square, whereas this one did. Okay, so let's try it on C. Okay, and then I want you to test your squares out. on your own. Let's see. Okay, so C, we have C lined up here. Board. See, this is a lot easier with your paper, so you can just line up your paper in the corner. Okay, so we see we have our line of our square lined up with the line of the angle, and we can see that C is a little greater than our right angle. So A is equal to a right angle. We said B, let me get this square out of the way. Oh. And this square. Okay, so A is equal to a right angle. B is less than a right angle. And C is greater than a right angle. So B, being less than a right angle, that type of angle is called an acute angle. And then if an angle is greater than a right angle, that angle is called an obtuse angle. Okay, so I want you to measure the rest of your angles and identify if they are acute or obtuse angles, or right angles. They might be right angles. Okay, here are our answers. D is acute, E is a right angle, F is an acute angle, G is a right angle, H, I, and J are all obtuse angles. If you have an angle like this, where all the points lie on the same line, that is called a straight angle. That is called a straight angle.